Oh,
Hey Taylor, how you doing?
good and you.
Coming down the stretch.
Uh,
For probably both of us. I've never done so much tutoring in a 3-day period as I have Monday, Tuesday, and Wednesday of this week.
oh, really?
Yeah, everybody in the country's finals are this week. I
Yeah.
presume yours are too.
Yep.
Okay.
This I have finals Wednesday, Thursday, and Friday.
Wow. Most in Colorado, most of them are done by today. So
Really?
I don't have a lot to do Thursday and Friday. If you need help tomorrow, let me know. I'm available.
Okay.
So what are we going to do tonight in our half hour?
Some and different identities.
Okay.
So I have cosine 95, cosine 55, minus sine 95.
Was this cosine 95 plus cosine 55?
No, times. And then it's minus sine 95
I get it now. Okay.
times sine 55.
In other words, they want you to know these sum and difference formulas forwards and backwards, right?
Mm-hmm.
Because what they're giving it to you here is backwards. So what is this? Is it cosine or sine? Sum and difference.
It's cosine.
And is it sum or is it difference?
It is different.
No, it's always opposite that.
Oh, so it's
It's sum. And what are the two angles?
95 and 55.
So this is the same as the cosine of 150 degrees. What's the cosine of 150?
Negative root 3 over 2.
And that's your answer. In other words, notice that each of these angles is a peculiar angle. It's not a multiple of 30, 45, or 60. And yet, by using the sum and difference identity, we're able to solve it. In other words, if we can take an angle and either put it together or split it up into something that is a multiple of 30, 45, or 60, we'll be able to solve it without a calculator. And that's what we did here. In other words, you didn't use a calculator to solve this, you used the trig identity.
Okay, let me write that down real quick.
Well, what's the general format of the trig identity? What is cosine of A plus or minus B? And when I ask that, I think it's important that you don't have that on a piece of paper in front of you, unless they're going to let you have a piece of paper on the test.
No.
Okay, if you have to memorize this, then you should start now, if you
Okay.
haven't already. The worst way to memorize anything is to have it on a piece of paper in front of you, and every time anybody asks you about it, you look at the paper. You will never memorize it if you do that.
Okay.
The way to memorize it is to treat it like flashcards. In other words, try to remember what it is, and if you can't figure it out, then look it up. But make it a two-step process, not. I firmly believe that. In other words, it'd be great. A great thing for you to have would be flashcards for each of these identities, where you had this on one side, and on the other side you had whatever goes over there. What does go over there?
Cosine A times cosine B. Then, would it be plus or minus?
Well, it's minus plus. That's the opposite of that. The important thing is to remember the sign is the opposite of whatever you started with.
Okay.
In other words, I could write this as two different identities. I could tell you what the cosine of A plus B is, And then I could give you a second one saying what the cosine of A minus B is. Well, this is just a short method of doing that. And what goes over here?
Sine A and sine B.
And what about the sine sum and difference?
It keeps the sign, so it would be sine A, cosine B, plus or minus, sine B, and cosine A.
You got it. Those are the two biggies to memorize. Now, you might have to know tangent. Do you know tangent?
No, I don't need to know tangent,
You
actually.
don't need to know tangent. Let's not even put it in there. Okay. Notice something about these. Each one has two cosines and two sines. So, all you really have to do is memorize that one. And when you memorize this one, know that it starts out cosine, cosine, opposite. That's all you have to memorize for that one. Because if you know it has two sines and two cosines, then you know what the rest of it has to be. Right? And then if you know that this one doesn't have anything together, in other words, it doesn't have a sine times a sine or a cosine times a cosine, then it has to be sine times cosine, different letters, same sign. This is automatic. You don't have to memorize this part. So really, to memorize both of these, you only have to memorize this much of it. If you memorize that much of it, you'll be able to figure out the rest. Agreed?
Yes.
Yeah, on both parts. And that's really the secret of trig, as far as I'm concerned, is memorizing as little as you have to and figuring out what the other has to be based on, whatever rules you know. In other words, it is necessary to think that, well, I got to have two sines and two cosines in each of those. You have to know that. But once you know that, then the only part you really have to know is that. Okay, what else you got?
Okay. I mainly want to go over the equations, really.
Okay.
The equations like reciprocal identities, the quotients, Pythagorean identities, double angle identities.
Let me test you on them. Here, I'm going to write the three primary trig functions. And the only reason I call these primary is that these are the three that are on the TI-84 calculator. They don't give you the other three. You have to know that the other three are reciprocals of one of these three. So, what are the reciprocal functions of each of these? Start with tangent.
1 over cotangent.
That's the easiest one to start with because that's the same. You're never going to forget that, okay? Now, there's only two others. There's secant and there's cosecant. Which one goes with which?
Cosine is secant, 1 over secant, and then sine is 1 over cosecant.
Notice
I remember that.
Notice there's exactly one co in every pair. In other words, sine can't go with secant because there's no co in that pair.
True.
One way to memorize it. As long as you know this one, then you'll never get these wrong. Okay? In other words, if I mistakenly put cosecant with cosine, I would instantly see there's two co's in it. That can't be right. Okay? So what is cotangent equal to?
Cotangent is equal to 1 over tangent.
Okay. So the other three are automatic. In other words, to memorize these, you really only have to memorize these three, and you know all 6 of them. Now, the quotient identities. What's that one equal to? And the only other one they want you to memorize is that one. Well, you don't have to memorize that. You know that's the reciprocal of that. So what does it have to be?
Cosine over sine.
So here's another case where you only have to memorize that one. And the other three most important ones are the Pythagorean identities, starting with this one.
Yes.
What's that equal to?
Sine squared plus cosine
Equals what?
1.
And what's
1.
And what's the second one? What's the second identity? Starts with tan squared.
Tan squared x plus 1 equals secant squared.
Good. Now, that's the only one you have to memorize. The third one you can base on this one. What's the third?
So that would be cotangent squared x equals cosecant, or is it cosine?
No, you got it. Cosecant. Now, the reason I said you don't have to memorize these is because this is the cofunction of tangent, and this is the cofunction of secant. Let's talk about cofunctions for a second. What's the cofunction of sine?
Sine or secant or cosecant?
Cofunction means, stick a co in front of the word.
Cosecant.
Cosine.
Or cosine. Yeah, my bad. Yeah, cosine.
What's the cofunction of tangent?
Cotangent.
And what's the cofunction of secant?
Cosecant.
Okay. So cofunctions are different than reciprocals. They happen to be the same for that pair. In other words, the cotangent is the reciprocal of tangent. It also is the cofunction of tangent. But with sine and secant, the cofunctions are different than the reciprocals. In other words, the cofunction of sine is cosine. Now, what does cofunction mean? It means this. And I don't know if you've even had this or not. I'm guessing you probably have. In other words, if I said the sine of 30 degrees equals 1/2, what angle? In other words, if I plug in 30, that means that the sine of 30 degrees is equal to the cosine of 60 degrees. Always. Or I could say the sine of 29 degrees is always equal to the cosine of 61 degrees. That's what cofunction means.
Okay.
Have you had cofunction? Has anybody explained?
Like, no, actually we haven't done it, but this still helps.
Okay.
I noticed
Yeah, no, this is true, and this would be helpful. And if you think about it, you know that the sine of 30 degrees is 1/2, and that the cosine of 60 degrees is 1/2. So this relationship makes sense. The only reason I bring it up is because when you're memorizing your identities, notice that this bottom identity is the cofunction of that and the cofunction of that. In other words, you don't really have to memorize the third one. You just have to memorize that one and that one. And know that the third one is the second one, only with cofunctions in front. In other words, all I do is cofunction of that's cotangent, cofunction of that's cosecant.
Okay.
So it makes it easier to memorize. So there are 11 primary identities. In other words, when you're doing problems where you're verifying trig identities, there's only 11 that they base it on. And that's the 6 reciprocal, the 2 quotient, and the 3 Pythagorean That's 11. But
Okay.
of those 11, you only have to memorize the first 3 reciprocal, right? Because once you memorize the first 3, you know the second 3. You only have to memorize the first quotient one, because if you know that one, you know the other one. And you only have to memorize these 2. So really, you only have to memorize 6 things to know all 11 identities.
Okay.
That's key to me. I mean, trig is all about memory. It really is. You have not had a math yet that requires you to memorize as much stuff as you're memorizing with trig. And so little tricks for memorization are very valuable.
And then lastly, the Pythagorean, the double angle identities. Yeah.
Okay, let's talk about the double angle. This is the easiest one because there's only one. What is that?
2 sine times cosine.
Good. And then this is the tough one because there's 3 of them.
Cosine, or 2 cosine squared x minus
Notice that all 3 of them, the trig functions are squared in all 3 of them. So I kind of start out by cosine squared minus sine squared. That's the first one.
Okay.
Second one has nothing. Go ahead.
Cosine squared x minus 1.
There's a 2. There's always a 2 in front. And the third one is kind of the opposite.
1 minus.
That's a little tough to memorize. But not really. Let's examine these 3 answers. What do they share in common? There's nothing but subtraction going on. There's no addition. Okay? That's helpful. There is nothing but 2's in front of the squares on the second and the third ones. In other words, this third one is almost the reverse of the second one, only it uses sine instead of cosine. So that's kind of helpful in memorizing it. And then this is peculiar because your trig identity is cosine squared plus sine squared, and this is cosine squared minus sine squared. So that's the way I memorize them.
Okay.
Now, which one you use kind of depends on the nature of the problem. Let me give you a problem. If I had cosine of 2 theta plus sine theta minus 1 equals 0, which identity am I going to use?
I would use sine cosine.
The bottom one.
How come?
Because it changes the entire equation.
Oh yeah,
nothing but sine.
Oh yeah, that would keep it all at sine.
And it turns it into a quadratic. In other words, notice what I get. I get 1 minus 2 sine squared plus sine minus 1. Well, that becomes minus 2 sine squared theta plus sine theta equals 0. I can solve that because everything's in sine. Everything's the same. And that's a quadratic. Never forget that just because it looks like a trig function, if it looks like a quadratic, it probably is. In other words, there's no difference between that and x squared plus x equals 0. That's a polynomial quadratic. This is called a quadratic in sine theta. And you solve it exactly the way you would solve any quadratic, by factoring. So that's what determines which identity you pick. In other words, if I go back to my original equation and I substitute, let's make that cosine theta instead of sine theta. Now I'm going to choose the identity, which one?
See that one more time?
If I'm looking at, you see what I have circled here?
Yes.
Let's say that's the problem.
We'd use the second one.
Correct. Because that would leave me with a quadratic in cosine. And I could solve it. In other words, the secret to solving trig equations, one of the secrets, is to get everything the same. In other words, if I tell you that sine x times cosine x equals 2 or 1, let's say, that's hard to solve because I got two different trig functions. If I said sine x times sine x equals 1, well, I can solve that because now I can take the square root of both sides. So I get sine x equals plus or minus 1, and I can figure out what angle x must be to give these two possible answers. So when you're solving trig equations, not verifying trig identities, but solving trig equations, that's where it really matters which identity you choose when you're looking at cosine of 2 theta. You want to choose whichever one is most helpful in solving whatever equation it is you're trying to solve.
Okay.
All right, we got 5 minutes. You got any last problems?
I have sine 20, cosine 40, plus cosine 20, and sine 40.
What is this the identity for?
Sine plus or minus.
Sine of what angle? And is it plus or minus of, and what's the other angle?
It would be plus or minus is the other angle too.
No, it's not plus or minus. It's, you got to know. In other words,
Yeah. Oh yeah, never mind. That's just the formula. It's just plus and plus.
good. Which means the sine of 60 degrees, and we know that that one is. It's square root of 3 over 2.
Mm-hmm.
So again, even though we have very odd, unusual angles that we would have, we would have to look those up in a calculator, by using the sum and difference formula, we don't have to look it up in a calculator.
True.
Back when I was in high school, there were no calculators. So if you had a trig function of an unusual angle, you had to look it up in the back of the book. There were tables. There was a table that told you what the sine of 1 degree was, the sine of 2 degrees, up through 29 degrees, and all the way through. And that's the way you had to do your unusual angles.
Oh. I have another one, like sine of 165.
Okay. Let's split that up into the sum or difference of two different angles that we know.
120 and 45.
Okay, now use your sum and difference. What's this going to be equal to?
Plus. This one would be sine.
So it's the sine plus 20.
Cosine 45. Then sine 45 and cosine.
What's the plus or minus sign between them?
It would be a plus. Then it would be sine 45 and cosine 120.
And we know all of those. In other words, we know what that is. We know what that is without a calculator. We know what that is, and we know what that is.
Mm-hmm.
And
so that would be square root of 3 over 2.
Well, this first one is square root of 3 over 2. What's cosine of 45?
Root 2 over 2.
And the sine of 45?
Root 2 over 2.
And the cosine of 120?
Negative 1 over 2.
So what we end up with here is root 6 over 2. That's multiplying those two, root 6 over 4.
Could we simplify?
Well, hold on. No, actually not. Plus, product of those is minus root 2 over 4. So I can take that and change it to a minus. And that's actually simplified. I mean, I could say root 6 minus root 2 over 4. So I could, combine those two fractions since they have the same denominator. But, so, if are your tests going to be multiple choice?
Yes.
So your multiple choice answer is liable to look like this.
Yeah, most likely.
So the only trick on multiple choice is knowing that this is the same as this. If I had to come up with an answer, I would be perfectly happy with that answer there. But that may not be the multiple choice answer. So.
Okay. Well, thank you for everything.
You're welcome. And
next year, most likely.
Have a Merry Christmas and Happy New Year, and I'll probably talk to you next year.
Thank you. Sounds good. See you in 2016.
All right, Taylor. Bye-bye.
Bye.